And about the authentication, actually, we have the second way to configure is the local. Because before we have introduced how to configure the capable portal on our Reyee Cloud, but actually sometimes if we choose another way, is configure the portal captive on local. So how to do this configuration? So actually, first we have to go to provide the captive portal first. So we create the local. And then here we can see some differences here. And before we use the inner, right? So it means the authentication action is acted by our Reyee Cloud. But except this, actually we choose the local. The local is means we do the authentication by NBR device. So after choose the portal page, we can set the login options, for example, the venture or the account. And after this, we create the portal page. We have to go to the NBR device. And for this, actually, we to enable the local authentication portal and disable other captive portal page. And then to switch to the local authentication. And for this part, actually, we have to enable two functions. First is the authentication, local authentication author. We have to enable it, and then we have to set the authentication portal by our cloud. And now we can see some configuration page. And here we have to enable the authentication integration with cloud. For this button, we have to enable. Then we can configure the local authentication by NBR device, not for Reyee Cloud. Okay. And after this, we have to add some policy. So for this policy, actually to do the synchronization with Reyee Cloud. So we can see this process. And now we add the policy here and to enable this policy and to set the portal template is we choose the cloud template. It means we use the template which is from the cloud, not created by ourselves. And then to set the policy name. And after this, we set the policy range. So for example, the 192.168.30.2 and choose the 254. And we choose two segments to do the authentication. So after this, actually, we can enable the local authentication. And here, we have to remember to enable the auto remember MAC. For this, actually, when the customer access to the network, we can remember the MAC information so that we will know this customer access to the network or not. Of course, here we also can to set the similar authentication way. Here we use two similar authentication MAC bypass. It means if the customer access to the network once and then next time the customer access to the network again, and we don't need him to access network and do the authentication. He can access to the wellness network strictly. Okay, so after this parameter, you can just set. And for the HTTPS redirection, if you enable it, It means you can use the HTTPS to do the portal. So this is the basic settings for local configuration. Okay, so next part, actually we can do the capital configuration about our local. And of course, to access the network, test the speed. So we can skip this part and to go on the IPv. So the service actually for IPv, we use the IGMP protocol. So first we will introduce the IGMP protocol for you. And here we will relate 3 kinds packets in IGMP. For IGMP protocol, actually, we provide like the IGMP version 1 and version 2 and version 3, right? So in common, we use the IGMP version 2. So in our Reyee Cloud, if you want to configure the IGMP and you have to enable the IGMP function and to choose which version you have to use. Okay, and then we back to the packet introduction. So here, in this topology, we can see 3 types packet. First is the query, and second is the report, and the third is leaf. Actually, for query packet, it's from the router to send to our host. So for query packet, we have 2 kinds of query packet. First is the common query packet, and second is the specific group query report information. And in this packet, actually, the router sends the query packet to our host. We have to focus on 3 parameters. First is the source IP, and second is the destination IP, and third actually is the group IP information. And for query request, the common query request packet, the source IP is root A's IP information, and the destination IP actually is the 0.0.0.0. It means for this router, he doesn't know the group you belong to or you want to ask. So for the first, the group IP information with the 0.0.0.0. And to next, we can see the destination IP to all the noodles. It means we will send this packet to root B, to host A, to host B, to host C. So in order to every host can receive this packet for the host IP, we have to set the 224.0.0.1. This means all noodles. This means the routers, the hosts can receive this packet. Okay, so this is the query packet. And after the host receives the query packet from the router, it will respond the report packet. We also have to focus on 3 parameters: is the source IP, destination IP, and the group IP information. So for the source IP, actually is the host A's IP. And for the destination IP is the group IP information. And for the group IP information, we can, for example, 224.1.1.1. This is the host report packet. And after other hosts receive this report packet, actually, the host B, host C, doesn't need to send the report information to root A. So it means we can relate the report separation for our host. And then, actually, before the 2 routers to send the query information, we also have to do the election mechanism. So it means at the beginning, the root A and root B will send the query packet to our host, but actually the root A can receive the packet from the root B, and the root B also can receive the packet from the root A. So the root A and root B will compare with each other to elect one router to become the querier, so that not every one router have to send their query packets. So it means the querier election mechanism. So for the query election mechanism, actually root A, root B will compare the IP address about every router. For example, the root A's IP is 101.1.1, and the router B's IP is 2.10. So we can say for the IP address, the root A is smaller than root B. So the root B will become the querier, okay, and the root B is non-querier. So this is the query and the report. And the third is the leave packet. So now for the host C want to leave this group, and we will send the leave group packet. And for leave group packet sent, and the router A receive this packet from host C, he also have to send the query report to ask who in this group. So for this query, actually, it's a specific group packet. It's different from the common group packet. So this is the IGMP. And after this, we can see maybe some problems happens in our multicast level 2. So what's the problems? And when the multicast source or IPv server will send the traffic to our router, and our router will broadcast this packet to host A, host B, host C, even though the host B not or can't or want to receive this traffic, but the switch still to send the packet to our host. So actually, it will waste the traffic on our link. So how to deal with this problem? So we use the IGMP snowpin. So in our hotel scenario, if we want to enable the IGMP snowpin, we can do it on our eWeb set. So next, what is the IGMP snowpin function? So here for host A and the host B will send the report information to the switch. It means I want to attend, I want to join the group. The group information is 230.1.1.1. Okay, and after this, our switch receives this packet. And at the beginning, the switch will to define for this group, does I have the routing metric, does I have the MAC entry about this group? If I have, I will flash the timer. If I don't have, I will generate the MAC table about this part and this group information. Okay, so now I find I don't have this MAC address about this part. So I will generate a multicast MAC table to record our information into table. So here is the MAC information and part information corresponding. So the part actually is a 1 for this part. And next part is the MAC. So we can see for this MAC address is not for the host address. Of course, it's not for the port address. It's corresponding for our group information MAC address. Okay, so we will generate the multicast MAC address table, and then we will forward this report to our querier. And after our querier receive the packet from PC and to send the packet just to host A, not for to host B and host C, because in switch we enable the IGMP snowpin function, and we just can find the MAC address table for part 1, not for part 2 and part 3. So we just to forward this packet to part 1. Okay, so this is the IGMP snowping to resolve our problem. And then let's take the configuration about IPTV. Okay, so first actually we go to the eWeb. So we can't configure the IPTV on Reyee Cloud. So we have to switch the eWeb set, and so that we can configure. And here we set the IGMP version is a version 2, right? And enable this function global. And then to switch to the IGMP sloping and enable the IGMP sloping function. Okay. And for the IGMP sloping function, we have to configure the IGMP status about our VLAN information. So now we choose the 130 to ask the IGMP VLAN. So here we have to enable the multicast status here. Okay, if we disable this button, the IPTV doesn't work. So we have to enable the multicast status on eWeb in IGMP sloping function so that the multicast status is okay. And then we have to save this configuration. This is the second step. Okay, then we have to configure the IGMP query information. So for query information, we have to create the VLAN information and to identify the querier. Okay, and here we add into the VLAN ID information, set the version ID, set the source IP address. This is the querier information. Don't forget to set this. And if you want to set the IGMP filter, it means you don't want to receive this IGMP group or traffic. You can use the IGMP filter function. And after this, actually, you can broadcast or play the IPTV so that you can see in L2 multicast routing, multicast table list, you can see the group information. And we learn the multicast IP address dynamically by the port. So if you find sometimes the IPTV doesn't work, so first you can to check the level 2 multicast information in this list. You have to find the multicast IP address. For example, now you have the group. The group IP address is the 224.1.1.1. So if in the list we can't see this list, it means the IPTV doesn't work. So you have to check the configuration in the eWeb. Okay, and if you want to build the static multicast IP address, you can use to create the VLAN information and the corresponding group information on this page. So if you find the group in your list, but you still can't to broadcast the source group information, you can use the heavier like the delay to check if you delay this group traffic. So if you find the delay, you can delete this list so that you can see the multicast traffic. So this is the multicast filter function. And after we configure the IPTV and the IGMP snowping and enable the multicast function in our eWeb on MBS device, we have to enable every function on every MBS device so that they can help us to transfer the multicast traffic. So after this, we will switch to another NBS device so that we can see to another NBS 3100, we also have to configure the IPv. It's the same step. The same step means first we have to enable the IGMP function and set the version is version 2. And second, we have to set the IGMP snowping function. Okay. And then we have to set the IGMP querier. And the fourth, actually, we have to check if we have the IGMP group information. After this, we also have to check if we set or create the IGMP multicast filter rules in our multicast group. So if we create, we can delete it so that we can access to the IPv. So this is the process for IPv configuration. Okay, we continue. And for the next part is the advanced function, includes the multiple WAN policy, roaming, and Wi-Fi optimization. And the new function is AI heat map, deliver report and alarms. So now let's learn some details about this part. So the first part is multiple WAN policy. Actually, here we will relate two protocols. First is the PBR, and second is the load balance. Okay. And for this topology, the PBR is a policy-based routing protocol. For this protocol, actually we use it to define next hop or which traffic do you want to transfer. So we use the PBR. For example, we can see this picture. Before we set the PBR in our network, we can use the common routing, right? So in the left, we can see the packet destination is a 1101. And when this router receives this packet, he will transfer this packet to 1101. And the segment is 24, right? And after this, we will to find or look forward our routing table. If I have the routing entries to 111.1.0 to this destination, if I have, I can help it to transfer. If I don't have, I will discard. This is the action for common routing. And the destination to 2.2.2, I will receive this packet and then to check the routing entry and then to transfer the packet to 2.2.2 for this segment. So if I configure the PBR information in our network, so how to do with our router? Here is the packet, and for this packet, I provide the 3.3.3.3. I want this packet to 1.1.1.1. This is this destination segment. So I do the PBR policy on the routers. So the routers will according to the PBR device and help us to transfer the packet to 1.1.1.1, not to check the routing tables. So this is the PBR. It will including the total tab, packet length, not other information, not just on destination IP address. We can include many tabs and many parameters to transfer our packet to the network. This is the PBR. So for the PBR, we enable the PBR. We can see the priority of the PBR is higher than the common routing table. For the packet input, and first we will check if you set the PBR. If you set, and we will to check the match statement. And if the statement is matched, we will switch to the next step. Is this entry permitted? Is permitted, and we can see the permitted and execute the PBR policy. Okay, so this is the process for us if we set the PBR. If we doesn't have the PBR, we will transfer the packets by including common routing. And if we can't match the entry, we also to transfer our packet including the common routing. And the permits, if we find the entry doesn't match or delay, we also have to transfer the packets by common routing information. So this is the PBR. Okay, and the next is the load balance. For the load balance, actually, in our network, we use a load balance for multi-one, and we set the load balance. For example, here is the LAN1 network, and we connect the two link to ISP1 and ISP2, right? And we will connect the line to ISP1 and the ISP2. Okay. So for this, we can see if we set the weight information, for example, the line 1 to ISP1 is 1. And the line 1 to ISP2 is 1. Is the 1 to 1. It means we will transfer the 5% traffic to ISP1 and the 5% traffic to ISP2. If we set the weight like the 1, 0 and 1, 1 is 3 to 2. So it means the 6% traffic will transmit to 1, 0 and the 40 traffic to 1, 1. So this is the load balance. Okay, so from this picture, we can see Lawman, we provide the 4 links. And for the 4 links, we provide the 500 and 500 and 400 and 100. If some error in our network, and for these 3 links, it doesn't work, we just can forward the packet through the link 4. And the bandwidth will decrease to the 100 Mbps. So this is the load balance. Okay. And now we can see for the multi-one configuration, we can switch to our website. So if we want to configure the multi-wire 1, and we go to the network wired and to see the multi-1 for this page. And here we can add to the link. Yeah, can anyone see the website? Is the website clear? Okay, so here we have 2 ports to connect with our internet, right? And we can use the PBR. So here, please notice, if you use the DHCP or the PPPoE for our 1 port connect, we can't to use the multiple 1 for this scenario. So we have to configure a static IP. And after we configure the static IP, we can to move the information to the static. So we can see these videos about our configuration. So here we can see we have 2 static information, right? And for the 2 static link, we can switch some service to different ISP link. So for example, we switch to the IPTV 130 to the ISP1. and 102 ISP2, 62 ISP2, and 42 ISP1. So it means for different VLAN traffic will transfer to different interface. This is the PBR function. It's very easy to use. And of course, after this, we also can use the load balancing to set how much traffic to transfer to the 1-1 and how much traffic transfer to the 1-0. Here we enable the load balancing and set the 1-1 and 1-0 weight. So here is the weight setting. If we set the 20 and 30, it means the 40% traffic will transfer to the 1-1. And if we set the 30, it means the 6% traffic will transfer to the 1-0. So you can choose how much traffic you want to transfer by 2 links. So this is the weight. Okay, so the next part is the awareness part. Do you have the problems about the advanced function? If you have the problem, you can send to the blank about the advanced function with PBR and load balance. Okay, if you don't have, I will continue. Yeah. If you have problems, you can send to me privately or send to the blank in public. Okay. Don't have the problem. I will continue. So for the next part is the rooming and the awareness optimization. For the rooming, actually, I think you are very familiar with this function. And in this picture, we can see 1 STA and 2 APP. So what happens if the rooming will happens? So we can say if the client will switch from the place A to the place B. So the client will find the service quality of the APP is better than the APA. So the client will choose rooming from the APA and APB. This is why our client will happen the rooming. And next is the awareness rooming scenario. For rooming this function, and our STA will move in this process, right? And first, the STA will associate it with AP, this AP, and then when the STA moves, so the STA will be associated for this AP. But for this process, actually the service is not interrupted, and the user identify is not changed. This means from the beginning, the STA IP address is 11111, and then we move to another place, and the AP2 provides the SSID service to STA, and the IP address via the 111 doesn't change. So this means the rooming successfully. For rooming, actually, we provide the 2 types. One is the level 2 rooming, and 2 is the level 3 rooming. So what is the differences between level 2 and level 3 rooming? So the differences is the VLAN information. VLAN information, okay. And we can identify the VLAN information according the level 2 or level 3 rooming. So for this page is the level 2 rooming, because for the STA, we remove to another direction, and the VLAN information for this AP is VLAN 1, and the VLAN information for this AP is VLAN 1. This means the VLAN information doesn't change. It's a level 2 network, level 2 rooming function. But for this topology, we can see for this SPA, we from the AP1 to AP2. But for AP1, the VLAN information is VLAN 1. And the AP2 VLAN information is VLAN 2. So it means the VLAN change. It's the level 3 roaming. So on our website, actually, if we disable the layer 3 roaming function, the roaming will fail. Okay, so in this topology, we can't roaming. So if we set the AP2 VLAN information is different from the AP1, actually, please remember to enable the layer 3 roaming. So this is the roaming. And during this process, for the IP address, whatever you are the layer 2 roaming and layer 3 roaming, the IP address is doesn't change. So this is the roaming table. And now let's see the roaming configuration. It's very simple. And I switch to the website to show you. Okay, it's clear for you to see our Reyee Cloud website. Can you see the website? Yeah, okay. So let's continue. And now we can do the roaming and to choose the optimization. And this list, we have the AI roaming function here and choose the AI roaming. And then we enable the AI roaming. And in here, we also can see for the roaming dashboard and the level 3 roaming. So for the level 2 roaming actually is enabled by default. It means if we use our device and the VLAN information is the same, it doesn't change, and we don't need to configure on our website. But we also can see for the level 3 roaming is disabled by the default. So sometimes you find your client doesn't work with the roaming. So you have to check whether if you enable the level 3 roaming information. Okay. And then when you enable the level 3 roaming function, and you have to set the SSID service. For example, for the A service, A office printer, and any other SSID, you have to set the layer 3 roaming for which SSID. So this is the level 2, level 3 roaming function. And after this, we can enable the AI roaming in this page. And after roaming, we can see some roaming dashboards. If you access to the Wi-Fi, and you can see the list here, and we back to the videos. And we can see the more information here, and we can see the logs here. Okay, the SPA is MAC address information, and we can see the view details information. And to enable the expert model and see the RSSI roaming information, roaming tab. So this is the details for AI roaming configuration. Okay, after this is the Wi-Fi optimization. For the Wi-Fi optimization, actually, it's also easy to do the configuration for us. We just to enable the WIO on our Reyee Cloud. So for the process, actually, for the Reyee Cloud, first to enable this function, and then we have to synchronize the configuration to our AP, and our AP will collect the information such as the SSAE channel and the signal strength and client status, and then our AP will do the optimization by our network, and after that, the AP will feedback the results to the Reyee Cloud. So let's take to how to do the optimization on our website. So we switch to the network wired and choose the Wi-Fi optimization. Okay, and then we can use the optimize now. So it's very simple, and it will spend maybe 6 to 10 minutes to do the optimization. You can wait for this minute. And after this, you can check the results of our optimization. For example, like this. After the optimization, and we can check the results. Here we can find from the beginning to the end, we change the channel. At the beginning, the channel is 1, and we switch to the 6. This is the optimization way. And for the channel, for this AP, we switch the 52 to 100. Of course, sometimes we will do some optimization on power. So here, the power before the optimization is a 23, and after then is a 45. So actually, the optimization we also have to do on our channels change, and the power, of course, include our power parameter. So this is the optimization. Okay, and after that, we will introduce the new function. It's the AI heat map. Actually, it's the AI heat map is the pre-sales tool for us to do the design for our network. And our AI heat map provides some function. Here is a list, like the product list created our own product list and support some formats like the PDF and PNG and DWG. Of course, can recognize our word automatically and edits the topology map. So let's do the demo for you and to know this function. Okay, so from this page, we can see in the list the home project and the AI heat map. So we switch to the AI heat map website. Okay, and now we can see the heat map page, and then we can go to my BOM. For this menu, we can create the BOM. Okay, and for example, we can create the hotel A and set this is the hotel scenario. Okay. After this, we add into a new placement. Okay, now we have create the hotel A's project. Here we can to upload our flow plane. So we use the upload flow plane. To click the button and then to choose the PNG or the CAD pictures, and we choose the one flow. And uploading this picture for our network, and in this process, we can recognize this picture by our Reyee Cloud. Okay, so after the uploading, we can see the detailed information about our project. So now we don't waste so much money, don't waste so much time. We just to switch the project we have created. Okay, we choose one. And adding to this project, we can see some features here. And we can add into the features like the product list, topology, placement design, placement map, heat map, and heat map for 2.4G and 5G CCTV coverage. So now we can choose the placement map. And we can see many detailed information in this topology. Okay. And we switch over to the placement. And here we can see the picture we have uploaded on our Reyee cloud. Of course, now we enable the 5G simulation. And then we can see the picture for AI heat map. And after this, we also can use the function on the list. Here is creates the scale and word recognition. We can use the create scale and set, like the area and all by length. We can choose two options. So we can add into the area information and length information and draw a picture. Okay. After this, then we can recognize the word on our picture and we can find the word we have identified. And if we find some line doesn't recognize, we can draw one line here. So we use the draw a word and we can choose which type word we can use. Maybe the thin, the medium, the thick. So we choose the thick, and to draw one line is add a word, okay, to tap this information on our picture. This is the placement. And then, of course, we also have to add our AP device. So here we can switch at the add product, and there is some list product here. We can see the RGIP device. We can see the route information. We can see the switch information. So all about this product we can add to our network. So now we choose the product like this is the ceiling AP. And after we choose this ceiling AP, we want to know the coverage of 2.4G and 5G. So how to know? So here we can see this is the 3 buttons. And the 2.4G actually is a simulation for 2.4G signal. And 5G is to signalization for 5G signal. And for the camera simulation, actually is for our camera. So we enable the 5G. And we can see for every device, the coverage range will appear on our pictures. So this is a simulation. And we disable the simulation. And now, if we want to export the detailed information about this project, so we also have to focus on the topology. And the topology actually will appear the device you choose. For example, here we can see the NBR device, NBS device, AP device. Also for this topology, we can remove and move the AP to any other device and to move the connection with the device. Okay, it's very convenient for you to create and to develop our network. And then if you want to export this detailed information about this network, you can use the export. Okay. And for the export, you can add some detailed information to AI heat map, such as the products list. We can see many product information here. Of course, about the price, we can set the price information. And except to export the topology. with whole network. And then we'll extract the placement design about our picture, about our design, about our segmentation, about the 2.4G and 5G. And also we can edit the company info, like add the company logo, company name, or the phone information. We can edit all of this function into our AI heat map. So this is the heat map, AI heat map. So then, and we choose the save locally. Save locally. For save locally, we can choose different formats like the Excel, PDF, and Word. So this is the AI heat map. Okay, let's back up to our PPT. So, except we can use the AI heat map by website, we also can do this operation on our phone. So we can see it's the same. First, we can to create the project and upload the picture, and then to choose, and then to set the IP device, and then we'll generate the project, and we can see the detailed information and do the operation to see the device list. So this is the AI heat map configuration for APP. Okay. So does anyone have the problem with this part? The AI heat map is a new function. So I think you need to do some practice by yourself or do some demo, and so that you will know this function. Okay, after this, let's introduce the last part, is the delivery report. I think you are very familiar with this function. The delivery report helps us to report our network quickly and to output the development about our network easily. So the delivery report we use to combine the information like the delivery time, customize the company logo, company name, and project introduction. So we can see our website, and we use the network, the delivery center, and use the project report, this function, and switch to this button. And wait for some minutes, we will see the project report here. And for every part, we can see the Office HQ project report contains the basic information. Okay, like the where network information and awareness network information, and the application information, of course, includes the device list and the device information about our APs and the topology. So every part actually you can use edit and to add the company log information here, and to add the project name, title, and phone and action, and add other some detailed information in report. So for the report, actually, we can output by PDF, by Word, and by Excel, any format you can use. So this is a delivery report. Okay, for this actually we can choose the format. Okay, and then for the local, we can see the report on our PC. Okay, so next part is the alarm. So sometimes maybe some errors or some device can't work normally. We have to locate it or find the error in our network. So how to deal with this network is the alarm function. And we can use the alarm function to find the error location and to find the problems easily. So now let's see this videos and to introduce how to deal with these alarms. And we can see if some errors or some alarms happened in our network, we will keep them to be red, right? And after we see these alarms and we can see some errors in our network, we have to deal with this alarm. And then the alarm will tip you VLAN 100 is not loaded to pass through the downlink, and we have to deal with the VLAN 100. So it helps us to locate the error, and we can find for this part is a trunk part. It means maybe some error for this part. Some configuration we haven't configured on this part. So we go to the configuration page, and we find for this part, actually, we don't have the VLAN 100 information, right? So here we have to add the VLAN 100 information and as the sub-interface configuration. So here we add the sub-interface and create the 100 sub-interface, set the IP address is a 192.168.100.1, and then to set the IP address. So after this, actually we can see the sub-interface has been created successfully. And then we check the configuration. And now we can see for this topology actually doesn't have some error appear on this topology. It means we have solved this problem. And then we back to our topology interview, and we can see the alarm is disappeared. So for the alarm function can help us to solve the problem and find the error location. It's a very easy and the good function for you to manage and maintain our network. Okay, so this is the Reyee Hotel Solution function introduction.